This is by far the worst idea I've ever had. Several weeks ago, I asked you all to submit theorems for a tier list video where I rank all the theorems and only the theorems that you comment. And Lord howdy, there are literally hundreds of comments. And some people took it upon themselves to name as many to name a whackload of theorems in there. So here it begins, I guess, between YouTube and Twitter. Uh, Also, by the way, just a PSA, because I feel like this is something that happens on Reddit posts, and so people ask for an answer, and then people will sometimes they'll reply, and they'll give like a one-word answer. And it's like, why would you bother giving that one-word answer? And it's one thing if no one else has answered the question yet. But then you look and you're like, someone gave a fully thought out, full paragraph answer. Well thought out, well explained. And then you see like 4 hours after that, someone gives their one word answer. Why? 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 Anyway. So all I'm saying is some of you guys, like Growth and Decream and Rock, you probably could have guessed. Maybe someone else has said that already. Okay, whatever. I'll stop complaining about the fans that make this channel possible, and we'll just get right in. Okay, Jordan Holder theorem. What are the first couple ones up? Uh, uh, Jordan Holder theorem, and so we'll pop that in, and we'll pop Barat Pretty. We'll pop that one in. I'm not looking at this article. Nah, you can't just link an article with a list of the most fundamental. You got to do the work to write out the theorems yourself. Okay, what else are we putting in here? I'll add a few and then I'll rank them and we'll go back and forth. So Van Kampen theorem, um, rate both fundamental group version and group weight versions. Nah. I'm not. I don't have time for that. And then irreducibility of MG. Okay. Jordan Holder theorem. I'm gonna put maybe solidly in C tier. Yeah, it's nice. It's important. Your composition factors are well defined, but it's kind of blasé. It's like it's an important theorem, but is it really up there? Barat Pretty. I don't know. That's also I'm gonna put it in B tier just because F1 is mentioned. I can't pretend to understand it at all. Van Kampen, honestly, I mean it's pretty good. It's pretty good. I don't know. It could go in C tier. Or B tier. I mean maybe. I don't know. I got to make more snap decisions though, because I have a lot of comments to get through. Yeah, the thing is, MG irreducible algebraic geometers are probably gonna kill me for saying this, but like, so what? You know what I mean? This is my ignorance, right? Deline Mumford's famous paper. Okay, I'm sure this was a big result. Maybe this is really important. This is my own ignorance showing. I don't know why I should care about this. So maybe it should be rated higher, but um, yeah, is this like completely fundamental to the moduli stat or to yeah? I don't know. People are gonna flame me in the comments. I hope you do, in fact. Um, okay, Dirichlet on arithmetic sequences. That's pretty good. Central limit. Central limit theorem. Gromov theorems on polynomial growth of FG groups. Okay, Gromov FG groups. Oh, this is what I mean. Someone's got. You guys are killing me. Do you have any idea how many I need to do? Oh my god, Jordan. Uh, um, let's go sub of GLNC. Uh, yeah. I don't even know how to say his name. That's bad. Don't tell him. Nobody tell him. Smeredis theorem. I don't even know how to say his name. Uniformization and 0-1 law. And 0-1 law. I don't even know what most of these are. I guess I'll have to look them up. Okay, Dirichlet. Honestly, I don't know. A lot of these I feel like are just C tier. You know what I mean? Like, no, I mean, the thing is, I like it, right? I love Dirichlet's theorem on, I love that it's proved with L functions and stuff. Okay, I'll put it in B tier. But, like, is it that important? Central limit theorem, A tier, easy. This is so important for the real world. Could it even be S tier? I don't know. It's maybe a little too basic to be S tier. Gromov's theorem on FG groups. So what is that even? Gromov theorem on FG finitely generated groups. Has polynomial growth. States that a finitely generated group has polynomial growth. Its word length grows like ND for some D if and only if T contains a nilpotent fundamental result in geometric group theory. I don't know. To me, I'm like, why do I care? C tier for sure. And Jordan Holder and MG reducible both seem more important to me. I don't know. Subgroups of GLN. I don't know. Let's see. Subgroups of GL and C. I don't know. Well, I don't need to look it up to know that it's kind of interesting. Yeah, again, I don't know. Probably most theorems are going to be C tier, to be honest. Most theorems will be C tier for me. Oh, this list is going to get out of hand. Smeredis theorem. Combinatorists are like dying or whatever he did. He did combinatorics, right? Arithmetic combinatorics, a result considering arithmetic progressions in subsets of the integers. Okay. God, that looks ugly. I guess there's worse bounds that have existed. Yeah, I don't even know what the statement is. An open problem. What does it say? Statement. The set of natural numbers has positive density, asserts that natural numbers positive density contains an arithmetic progression of length k for all positive integers. I don't know. Everything C tier. I don't know. Uniform and of course this betrays my predilections. Uniformization theorem. Oh, for Riemann services. I as a geometer am willing to maybe put this up in B tier. There's a bit more. Oh, this is gonna just get stupid soon. Yeah, and what's the 0-1 radiograph theorem? Zero one law for graphs. Any property expressible in first order logic. Quantifying over vertices, but not sets of vertices in a random graph. The probability that large random graphs, other approaches. Oh yeah, the random graph. I'm putting this one in B tier for sure. This is actually very interesting, and Yeah. Yeah. Okay, no, no, there's so more. Facebook synchronicity wins? What? Is that a theorem? Or is this guy like plugging himself? Uh Hellman-Feynman theorem? Oh my god, there's all these weird theorems I've never heard of. Why am I doing this to myself? Uh Hellman-Feynman Kuranishi's theorem? Never heard of this. Modularity theorem. Okay. Finally, we got a real one. Modularity theorem. Hironaka's theorem? Don't know it. Don't know it. Okay, what is Hellman-Feynman? Hellman-Feynman theorem. The derivative of the total energy with respect to the parameter of the expectation value. The derivative of Hamiltonian. The theorem states this. Yeah, I don't know. That seems super basic. I mean, maybe it's really important, but proved independently by many authors. Again, this is my own ignorance, but like, yeah, I don't know. Is that all there is to it? I don't know. I'm gonna say D tier. It doesn't seem that interesting. Kuranishi's theorem. Kuranishi's theorem. Critical condition on exterior differential systems. Blah blah blah. Okay, I've never heard of it, so D tier, D tier. I've never heard of it. Modularity theorem, S tier. Obviously, super goated, super impossible to prove, unlocked a million new worlds in mathematics. Easy, 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 easy. Hironaka's theorem. Let's see. Oh, and resolution of singularities for any algebraic variety. That's pretty good. That's pretty good. I'm gonna say at least B, maybe even A. Maybe even A. Central limit theorem is definitely more important, but yeah, I'll put it up there in A tier. Toplitz's theorem. So we've got Toplitz, universal chord with a CH. I don't know what that is. Darboux theorem. Darboux theorem. Arrow's impossibility theorem. I've heard of that. What is this? Quillen-Lichtenbaum conjecture not fully proved. Boo, doesn't count. Milner-Block-Kato conjecture? No. It doesn't count. Those are conjectures. Barbeck, okay. Barbeck and Reese. Again, so many people have said Reese. Like, associativity of addition in Z. I'm not even putting that on the list. That's too basic. That's not even a theorem. Ordering of the natural numbers? No. Identity functions biject? No. This is all sub D tier stuff. That's all sub D tier stuff. Toplitz theorem? Question mark. Silverman Toplitz theorem or Hellinger Toplitz theorem? Now I don't know which one. Maybe Toplitz theorem real analysis. Real sequence converges to a sequence such that blah blah blah. Really? Is that all it is? D tier. I've never heard of it. D tier. What was it? Unichord theorem, something like that. Universal chord theorem. Universal chord theorem. In mathematical analysis, universal chord theorem states that a function, if it's continuous and satisfies this, then every natural number... What? Okay. Why does this even matter? A generalization of Raleigh's theorem? Okay. I don't know. D tier. D tier, basic. Never heard of it. Darboux theorem. Darboux theorem states that every function that results from the differentiation of another function has the intermediate value property. Differential functions satisfy IVT. It's giving me C tier vibes. That seems, I'm not so familiar with it, but I could believe that it, deserves something better. Arrow's impossibility theorem. A fundamental concept in social choice theory, proving that no ranked voting system, can perfectly satisfy a set of seemingly reasonable fairness criteria. Right. I don't know. It's interesting. It's definitely interesting, but like, how strictly do we interpret this in our real world? I don't know. Oh, where did it go? Yeah, I feel like it ends up in D tier. Barbeck theorem. What is Barbeck? Barbeck monadicity theorem gives necessary and sufficient conditions for a category to be equivalent to a category of algebras over a monad. Again, I'm sure this is like a fundamental theorem, but it is all just, well, no, it doesn't. No, you belong in D tier. Barbeck for sure. Reese representation. I'm actually gonna go for B tier. Pretty basic. Yeah, but it is important. Galois correspondence for covering spaces. So technically, I can wrap up. I mean, the algebraic version is like covering space theory for schemes, which is different than the topological one. So maybe I will call them different. Euler product for normalized cuspidal Hecke eigenforms. I'll call it Euler cusp E maybe. Goursat's lemma. Poincaré duality. And Brouwer's fixed point theorem. Different Brouwer though, right? Bro failed to be constructivist big time. I mean, there also is constructivist Brouwer. Or no, wait a second. Wasn't it the same Brouwer? Because I think the story goes that he wanted to work in logic the whole time, but that he no, it wasn't like respected enough. So he was like, fine, first I'll go have a very successful career in topology so that I can justify doing logic for the rest of my life. So I think it actually is one and the same. Yeah, Galois covering for spaces, definitely B tier at least. Definitely B tier at least. It's pretty good, and that theorem does make the scheme version possible. So it's tempting to put it into A. The thing about the Euler product for cuspidal Hecke eigenforms. I don't know. In the grand scheme of things, like, I know this will be shocking to some people because I'm a Langlands boy, but like, I don't know. I don't really care that much about it. Gursat is definitely moving up. Let's say, I mean, this is an important thing, an important aspect of the proof for like, complex analytic functions to do their thing. So yeah, Poincare duality. Poincare duality. Definitely. I mean, it's cool, but I don't know. It's not. Doesn't seem. I don't know. Is it a B tier? Is it a B tier? I mean, I guess it's up there with Van Kampen, right? Uh, yeah, I guess it's better than all of these things. And Brouwer's fixed point theorem. I don't know. Pretty basic actually. Pretty. I'm gonna even put it in D tier. I'm gonna even put it in D tier because it's non-constructive. Yeah. Oh, okay. So, yeah, R4, the R4 theorem, AN simple. Yeah, these are good ones. Fatou's lemma, and contraction mapping theorem. Contraction mapping theorem. Eisenstein's criterion, and Gödel incompleteness. Now we're getting into some real ones. Now we're getting into some real ones. R4 differentiability theorem. This is mad. So this is going in A tier for sure. The proof is not easy. The result of the theorem extremely surprising. Yeah, easily A tier. Easily A tier. Maybe S tier. I may rearrange some of this later. AN being simple. That's a I mean, this is part of the classification of finite simple groups. So if I don't put this in A, I mean, it's pretty important. It's pretty important. I mean, a consequence of this is basically, insolvability of the quintic, although technically we had proofs before that. Yeah, I mean, AN simple on its own isn't maybe it even gets demoted to C tier, despite the fact I'm an algebraicist. Maybe it even gets demoted to C tier because that on its own, it's not. I mean, it's a very good theorem, but Fatou's lemma. This is like the one in measure theory, right? I mean, it's kind of basic. It's kind of basic, to be honest. Um, Fatou's lemma. Yeah, I don't know where to put it. Yeah, maybe also C tier, just kind of basic. Um, is it kicking out other things in here? Wait, 1, 2, 3, 4, 5, 6, 8. Are we running out of room already? Contraction mapping theorem. What if I make the screen bigger? Um, right. Okay. Let's see. We'll see what happens when I try to put more in. Contraction mapping theorem. What even is that again? Oh, this is Banach fixed point. We already ranked it. So maybe I can delete that one. Whoa. What happened? Okay. Delete? Okay. Contraction mapping theorem deleted. What's the other one? Gödel's incompleteness theorem. Obviously, this is S tier level stuff. Obviously. Crazy proof, crazy consequence, crazy meaning. Earth shattering realization for all of mathematics. Obviously, S tier. Eisenstein criterion. Honestly, I use it so much. Um, it's C tier though for sure. Good theorem, solid theorem, but kind of baby stuff. The FHHF theorem. I don't know what that is. I'm already losing my voice. What is it? What does this theorem even say? Prove the FHHF theorem using as much abstract nonsense as possible. Oh, right. Okay. Exact functors commuting with homology. I mean, it's important, but it's kind of an exercise, right? FHHF. Wedderburn Artin. Okay. Axe growth and Deek. Splitting lemma. And the me better than you theorem. Yeah, that's definitely F tier. So FHHF, yeah, again, like important, but is it replacing some 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Okay, there's 10. Wedderburn Artin theorem. As an algebraicist, I should remember this off by heart, but classification theorem for semi-simple rings. Yeah. Yeah, this is actually pretty important. I don't know. I'm tempted to make it B tier. I'm such an algebraicist. Okay, let's see. There's 8 and B tier. Right. So that okay, it is not making them disappear. Great. Axe growth and Deek theorem. I also don't remember what that one says. Sorry. Sorry, not sorry. Axe growth and Deek theorem. In mathematics, Axe growth and Deek is a result about injectivity and surjectivity of polynomials. If P is an injective polynomial function from an n-dimensional complex vector space, then P is bijective? A counterexample over C would translate into a counterexample over an algebraic extension of a finite field? Okay, that's kind of crazy. That's kind of crazy. I will go with B tier, actually. I know I'm probably making y'all mad right now with some of my choices. But the splitting lemma? There's probably a lot of different things called the splitting lemma. So I'm just going to pretend it's the first one that comes up. What equivalent stuff to splitting? Nah, this is like D tier. That's just like a homework exercise. The snake lemma. Have not done that yet. Snack. Oh my god, Nikolai, you're killing me. Look at all these things I've never even heard of. Finite geometric series sums to that? Nah. Not even making the list. Non-existence of surjections from X to P to X. That I will say Baker Campbell Hausdorff. Hilla Yoshida, I don't even know. Friedman translation of all AE theorems of PA not needing lem? I have no idea. I'll look it up. An undecidability of mortal matrix problem? I'm gonna say I'm actually not even. Here's the thing. I don't know. I've never. Okay, snake lemma. Snake lemma. We're definitely putting in. Ugh, it is kind of a homework exercise, but it is important. I'm such an algebraicist. Uh, yeah, surjection. This is easily A tier. The proof is just simple. The consequences of it are enormous. Baker Campbell Hasdorf. I'm gonna put that maybe in B tier. Useful but not crazy. Hilla Yoshida theorem. What does that even say? Nah. Characterizes generators strongly continuous one parameter semigroups of linear operators and Banach spaces. Widely used in the theory of Markov processes. I don't know. Functional analysis probably gonna kill me right now, but D tier. What the hell is a Friedman trend? What the hell is this theorem? I don't know. Nikolai. This is, I know you're probably gonna call this an S tier theorem, but a method for transforming proofs in classical Pinot arithmetic to proofs in intuitionistic hating arithmetic. A central result derived from all those are principle in that. Okay, I don't fully grok the meaning of this, but you know what? I will grant you that it smells like B tier type material, okay? I'll grant you that it smells like B tier type material. Mortal matrix. What's the mortal matrix problem? I mean, any undecidability result is kind of goated, but oh. Well, there's a set of n by n matrices with integer coefficients where the zero matrix can be expressed as a finite product. Undecidable. And also seems kind of like it has... Seems like that could have real world implications. I'm going to put that up in B tier for sure. Easy. Pumping lemma. Never heard of it. Pumping lemma. Some of your streams feature lean lately. Curry Howard Lambeck correspondence must be high in your tier list. Is it though? Because I remember someone like the correspondence isn't really a theorem though, right? It's not really a theorem. It's just sort of like an idea, right? The correspondence is just an idea. Like, I guess someone said that there's some part of it you can turn into a theorem. So I don't know if that even really counts. I don't even know if that really counts. Functional analysis trio. Okay. What do we got? We got Bear. We got Banach's theorem operator. Okay, I don't know what that is. And Lebesgue theorem for monotone function derivative. Great Picard. And Harry Ball theorem for the meme, obviously. Harry B. For something more serious, Bézou's theorem, from which the fundamental theorem, from which FTA follows immediately. Do you mean number theory Bézou, or do you mean algebraic geometry Bézou? FTA, you must mean number theory Bézou. But the fundamental theorem of arithmetic follows from it? Is it not circular in some way? I don't know. How much more do I have to go in these comments? Jeez. Oh my god. Um. Oh my god, this is bad. Guys, this is bad. Where was I? Okay. Okay, let's just do this round and you know, we'll get through this. Bezier number theory, yeah. So pumping lemma, no idea what that is. Fundamental concept in formal language theory, stating that any sufficiently long string in a regular language can be pumped to create a new string that remains in the language. Okay. I don't know. I don't care. D tier. Bear theorem. Let's say C tier. Definitely useful, but also pretty basic. Banach's theorem on operators. Banach's theorem on operators refers to foundational result. Several foundation results. Open mapping theorem. Right. Open mapping theorem, closed graph theorem, all that stuff. It's tempting to put it in B. B for Banach, yeah, let's just make the choice. B for Banach. Lebesgue theorem, monotone function derivative. What is this theorem? Lebesgue's theorem states any real valued monotone function on any interval is differentiable almost everywhere. It's a cool theorem, but does it really matter? Does it really matter all that much? I don't know. C tier maybe? C tier, let's say. Great Picard's theorem. Which one is that again? I should know that one also off by heart. Great Picard theorem. Picard's great theorem. Oh yeah, the Great Picard theorem has essential singularity. Yeah. It takes on all possible values. I'm tempted to even put it in B. You could say that it goes in C tier, but it's a pretty badass result, I'll be honest. Obviously, Harry Ball theorem for the name alone is S tier. Not much that needs to be said about that. Bézier's theorem and number theory? No, just too basic. Okay. Leverrier fixed point. Leverrier fixed point. Stonk's theorem. We got Stonk's theorem here. Licorice twist theorem. I'm gonna start just theorems I've never heard of. I'm just gonna start putting in D tier because I've never heard of them. Green Tau. Roth's theorem. Rank nullity. Rank nullity one. Okay, at least I only got 3. Rank nullity theorem. Spectral theorem for Hilbert spaces. And Quillen-Suslin should be top because of the channel name. You know that that's not how this works, Boris. Okay, Leverrier fixed point theorem. I know that a whole bunch of I know that a whole bunch of other theorems are consequences of this, like diagonalization and stuff. Yeah, I mean, we kind of have to put it in S tier, right? Because obviously Cantor's theorem is S tier, and Lever generalizes it, so it kind of has to be S tier. Stonks's theorem, yeah, let's say B. Licorice Twist, D. I've never heard of it. Green Tau. Oh, is it just? Oh, this is just Green's theorem. No, Ben Green and Terence Tao. Okay. Sequence of prime numbers contains arbitrarily long. Probably this was a big result, right? Probably this is one of the things that made him so famous. So I'm just gonna like play it safe and put it in A tier. Ross theorem, that's pretty basic, isn't it? That's pretty basic, isn't it? Ross theorem. Oh no, Ross theorem. Yeah, this one I'm gonna say is B tier for sure. B tier for sure. Definitely some interesting like approximation stuff going on for number theory. Rank nullity. Yeah, I don't know. D tier, too basic. Spectral theorem for Hilbert spaces. I'm gonna say that's pretty important. I'm gonna put that in B tier actually. Quillen-Suslin. Quillen-Suslin theorem, also known as Serre's problem or Serre's conjecture. Relationship between free modules in the geometric setting. Yeah, I'm sure this was a very difficult and impressive to prove theorem, but I don't know. Does it matter? We did Stonk's theorem, Tarski's theorem for RCF. I don't even know what that is. Tarski, RCF, Myhill isomorphism. I don't know. I've never heard of them, so they're gonna go in D tier. Droopy pizza theorem, is that real? Hang on, I need to know if it's real. I need to know if that's real. The physics principle of explaining why. Oh, okay. It's a practical application of Gauss's theorem egregium. Okay. We'll go. If it's egregium, we'll put it on there. Frobenius reciprocity, universal approximation theorem. You never hear about it in its formality. Universal approximation theorem. Let's take a look. A neural network with at least one hidden layer. Wait, is that it? Okay, it sounds like it's important to neural networks, so I'll just give it like a B because I guess it'll take my job one day, so but anyways, RCF, never heard of it. Myhill isomorphism, never heard of it. D tier. Theorem egregium, let's put it in A tier because it has to do with eating pizza and everybody loves pizza. That's my justification. For Venus reciprocity, look, this is gonna hurt me as much as it hurts you. Um, I almost want to put it in D tier. It's pretty basic. I'm gonna put it in C tier. Um, but it's like it's one of my favorite theorems ever, I would say. Universal approximation theorem, yeah, you get B tier just because you'll take my job one day. Okay. Oh my god. There's so many. Hodge. Hodge and Lefschetz. They're pretty related, these theorem. Hodge, Lefschetz. Atia, Singer, Index. Yeah, I think that one comes up a lot. Contraction mapping we did. IVT. No. IVT. Fixed point theorem? Which fixed point theorem? Contraction mapping is kind of a fixed point theorem. No, I don't know. IVT. Salamander lemma. Salamander lemma is somewhat familiar. I will look it up. Oh my god, no. No, oh, okay. I'm sorry. I'm not doing that. I'm sorry. I'm sorry. No. No, 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 no. I'm not doing that. Well, most of these are done. Okay, how about this? I'll do some. Okay. Hodge decomposition. What does that say exactly again? Yeah, Hodge decompositions. I don't know. C tier. C tier theorem. Lefschetz decomposition. If I understand it better, it might not be C tier. It's C tier. Atia Singer index theorem. Probably gonna put that up in S. Very important. Applies to a whole bunch of stuff. Algebraic geometry, differential geometry was super hard to prove. It's basically like growth and decrement rock or something. IVT is D tier for being non-constructive. Uh, Salamander lemma. Salamander lemma? What is this? Fundamental lemma. Maybe I don't know this. Okay, D tier. I'm just gonna put it in D tier. Nakayama, Azumaya, Krull. I don't know. That could be any one of their theorems. Hilbert basis. Hilbert basis. I'll say. I don't know. C tier, I guess. C tier. Most of these I don't know. Stonks we did. D tier. Never heard of it. Gauss Bonnet. Gauss Bonnet. Right, which one is that exactly? Oh. No. What have I done? Oh, okay. I thought I started a new page. Gauss Bonnet. Right, that one. That is. That one's hard to say. Hopdidealsats. Mackie. Oh man, you put so much. That's not fair. That's not fair. Hopdidealsats. Mackey's theorem. And Art and Wedderburn. Wait, didn't we do? We did Art and Wedderburn. Okay. Gauss Bonnet. Okay, I'm willing. Wait, where did it go? Oh yeah, I'm willing to put it up in B tier even. I'm willing to put that up in B tier. Hopdidealsats. Remind me. Bound on the head of principal ideal commutative ring. Yeah, I don't know. C tier. Actually, D tier. I don't care. Mackey's theorem. Let's put this up. Ooh. B tier. I'm not a real representation theorist if I don't, but I don't know. Does it really? No, it doesn't deserve to be up here with some of the. Well, hmm. Okay, it's a tenuous B. It's a tenuous B for me. Ugh. How much more do I have to go? No. No. Oh my god. Where were we here? Okay, at least I'm starting to see more repetition, so that's good. Try to get at least 3 or 4 theorems which are equivalent to choice. No. No, 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 no. AO, I'm putting choice as 1. D tier, obviously, for being non-constructive. Uh, oh, I mean, actually, axiom of choice is an axiom, so it shouldn't go anywhere. It shouldn't go anywhere. Crap. No, why is it here? How do I delete that one? Crap. Okay, pretend it's not there. I don't want to press the delete button on the side because I think that might delete the whole tier. I don't want to do that. But okay, equivalence of axiom of choice. Nah, I don't care about equivalence of axiom of choice being equivalent to these things. Who cares? Poincare duality we did. Universal coefficient theorem. Universal coefficient theorem. Yoneda. I think we did Yoneda, right? No. Did we do Yoneda? I don't know. I don't remember. Yoneda. Fried Mitchell. And Hurwicz. Classification of finite simple groups. Classification of semi-simple Lie algebras. Oh, why is there so many? Oh my god, I don't know. I'm just kind of grumpy today, I guess. I'm tired. I've been sitting still for far too long. Um, yeah, I'm kind of tired. I wonder though, will the comments reset if I do this? I don't know. We're gonna I think I'll pause and make this part 1 after this. Null-Stollen-Stats I think we did. Durham theorem. Durham theorem, I don't know. Eilenberg-Steenrod axioms for homology. Those are axioms. They're not a theorem. Friedman's classification of 4D simply connected manifolds. And solution to 4D Poincare. Okay. Universal coefficient theorem. Universal. Right. Pretty good, pretty useful. C tier, I guess. Yoneda lemma. It's kind of basic. It's kind of basic, right? I'll put it in C tier. Freud Mitchell embedding theorem. Um, I'm almost am gonna put it in A tier because it's very nice to work with elements. And I know there's all these snooty people out there that want to work without their elements, but screw them. That's what I say. Hurwick's theorem. All nice and useful, but again, I'm gonna put it in C tier. Like, is it that crazy? This is nuts. This is the worst tier list ever, guys. What am I doing? I put Hodge in C tier. I put Quill and Sosslin in C tier. What am I thinking? There's no way. There's no way. Hang on. Some of these have got to change, right? I mean, I don't know. This is kind of nuts, though. I wonder. Okay, classification of finite simple groups. This is easily an S tier theorem. Easily an S tier theorem. Um, what more to say about it? Classification of semi-simple Lie algebras. It's just not as impressive, you know. B tier for sure. Maybe even A tier, I would say. Maybe even A tier, I would say. It's just not. It's just nowhere near as impressive though, as classification of finite simple groups. De Rham's theorem. Also pretty cool. Gonna put that in B tier. Four-dimensional Poincare. I don't understand how important or impressive it is. Wait, no. This is a classification of 4D manifolds. I don't know. That's only one dimension, man. That's only one dimension. Maybe the proof is very impressive, but I don't know. I'm gonna put that, and you know, I don't even care about 4D Poincare. It's nothing on the 3D Poincare. Do you mean Cantor, Bernstein, Schrader? Okay. I don't know. I'm just tired and grumpy. I need to eat more. I think is what I need to eat more. Um, so that's gonna be the end of part one, I guess. We're not even halfway through the YouTube comments. And I guess I will see you guys for part two. Okay. It's a new day. For you, it's a new second, but for me, it's a new day. I'm recently fed, and I am somewhat rusted. For some reason, I'm still not enjoying this, but we're gonna get back to it. Schrader, Bernstein, Cantor, Schrader, Bernstein. Put some respect on these guys. Gelfand Nymark. I do know that one. Let me just remind myself. Right. An arbitrary C star algebra is isometric. Yeah, yeah. Gelfand Nymark. Urshan's lemma. Urshan. Cauchy residue. Let's take a look. So Cantor, Schrader, Bernstein, pretty goated. I'm tempted to even put it in A tier. No, maybe it deserves just B tier. It's not that important. I mean, it is, but you know what I mean. Gelfand Nymark, I am going to put in A tier. That does belong in A tier. That's a pretty based result, to be honest. Urshan's lemma is definitely C tier level stuff. Undoubtedly super important. Math is topology is like nothing without it, but I don't know, like too basic kind of. Cauchy residue theorem. Gonna put it at least solidly in B tier just because it's so incredibly useful. Modularity theorem's been done. Freudenthal suspension theorem. Let's just call it Freud. Kuratowski's closure complement. Kura CC? I don't know. Harry-Ball theorem already did. CeLO theorems. Construction of Cantor-Lebesgue function. Does a definition count as a theorem? Kind of. It's a proof that some such thing exists. What is the motivation behind it? Actually, Cantor-Lebesgue construction of Cantor. Wait, what is a Cantor-Lebesgue function? Cantor function? Cantor-Lebesgue function. What is it? The section construction related to the construction of the Cantor set. Okay, it goes in D tier because I don't know. I haven't seen this before, so immediately is going in D tier. Freudenthal suspension theorem, definitely. I'm gonna put it in a solidly C. Workhorse of algebraic topology. Is that right? Am I misremembering? Is it more important than I'm giving it credit for? It could be. Kuratowski. So this is a hard one because, you know, I love this exercise. It is so awesome, but it's so unimportant. But I really love it as an exercise. So, ooh, it kind of belongs in D tier. I'm gonna put it in C anyways. CeLO theorems. I think I saw someone else say CeLO theorems were D tier. No, they're too important. But again, it's like they're also very basic, you know, so solidly C tier for sure. Cyclic decomposition theorem. In graph theory. Yeah, that definitely seems like D tier. PBW, I think we did. Zemeretti. I'm so sorry, I don't know how to say that. We did another one of his theorems, but regularity. Did we do this one as well? So it said a graph can be partitioned in a bounded number of parts so that the number of edges between parts are regular. I don't know. Is that really all that crazy? I don't know. Well, okay, Reg lemma. And what else we got? Van Kampen. We've done Honey Burrell. And Jordan curve theorem. The Jordan curve theorem, I'm just going to immediately say is incredibly B for based. Not because it is important, but it's also, the proof is disproportionately hard compared to how obviously true it is. So I'm going to put it in B tier. Cyclic decomposition, I don't know. That seems like D tier. So does regularity lemma. Come at me, graph theorists. I like graph theory. You guys know I like graph theory, but Honey Burrell also, Yeah, super base. It's at least C tier. It's at least C tier, I would say. Um, yeah. That was easy. Okay, I'm making quick work of this. Okay, Vile character formula. Did I do that already? Vile character formula. No, I don't think I did that one. We did modules over a PID. Vile character formula. Oh my god, Ken, you're killing me, man. You are killing me. Point set topology ones. Ugh, at least we've done a bunch of these already. Honey Burrell, Tikhonov. Is Tikhonov technically equivalent to choice? Uh, is Tikhonov equivalent to choice? Follows from choice. Yeah, so it's equivalent, so we don't need to worry about that. Borsuk, Ulam. Bear category theorem. I think we did Bear, and we did Harry Ball theorem. MVT, IVT. I didn't even list. Oh, orbit stabilizer theorem. And Brouwer's fixed point theorem. Did we do Brouwer's fixed point? Ugh. Is that subsumed by like Banach fixed point and stuff? Oh, and then critical race theory. Can't forget to do critical race theory. Oh my god, Ken. No, look at you. You're the. Oh my god. Lagrange. Rank nullity theorem we've done. Prime number theorem. Binomial theorem. No, come on. That doesn't even rank. Doesn't even rank. Four color theorem. FLT. I mean, that's kind of subsumed by modularity. Yeah, four color theorem. Four color theorem definitely. I'm tempted to put it in S tier. Computer assisted proof, super controversial. The fact that it's controversial makes it like, yeah. Val character theorem. It would be insane for me, a representation theorist, to only put this in C tier. But I don't know. I'm just not feeling like B. Okay, it belongs in B. It belongs in B. It does belong in B. Borsuk Ulam, yeah, that's C tier. Again, just sort of like super important but standard workhorse stuff, you know. Orbit stabilizer theorem, I'm gonna say the same thing. Truly one of my favorite theorems, but critical race theory, I'm gonna say is A tier theorem. Critical race theory is A tier theorem. Because okay, yes, it's basic and blasé, but it's ancient and basic, and I feel like that changes it in a way that like, you know, Borsuk Ulam, like maybe it would be A tier if we had discovered Borsuk Ulam 4,000 years ago. Because it's really, you know, will have stood the test of time by now. So I guess literally everything levels up over time. Actually, maybe that's not true. Maybe that's not true. Maybe not everything levels up over time. Lagrange's theorem, I don't know, D tier. Just way too basic of a thing. Prime number theorem is it A or is it S? I'm going to say A. Prime number theorem's an A tier type theorem. Independence of continuum hypothesis. That's interesting. The BKK theorem? Come on, you can't be saying stuff like that. I don't know what that means. I don't know if it's short for something I already know. No, I don't know what this is. D tier. D tier instantly. What else we got? Classification of finite simple groups we did. Lagrange we did. Stark-Heegner. Stark-Heegner, Moonshine, Faultings, Abel Ruffini, and CeeLo. Oh, this was the person who said their CeeLo's F tier. Yeah. Freudenthal spectral theorem, is that different? Hang on, is that different than Freudenthal suspension theorem? Is that just a typo? Freudenthal spectral theorem. Mathematics, Freudenthal spectral theorem is a result in Riesz space theory. Yeah, I don't know it, so D tier. I'll put that in now. And I may as well do H cobordism theorem. May as well do H cobordism theorem. For a cobordism to be trivial. Yeah, again, I'm gonna make so many people mad, but D tier. Independence of continuum hypothesis, I'm gonna say, is actually an S tier type thing because, unless I'm mistaken, this was one of the first like legitimate statements that we proved to be independent. By which I mean, yes, we had, you know, we already knew that there were other statements that were independent, but like this was one we were trying to solve ahead of time, right? This was one we didn't know ahead of time. We tried to do a lot of work on. It was sort of the first one of the first standalone statements that really turned out to be independent. So I would call that S tier level stuff. BKK, I don't think I know it, so D tier. Stark-Heegner. Ooh, right. Yeah, that's a good one. And it is kind of important. That's kind of, I don't know. Is it important enough for B tier? Part of me likes it. How much I like it is like an A tier level theorem, but I don't know. Monstrous Moonshine. It's also hard to not put that in S tier. I mean, because it's just so crazy, right? It's just so crazy. Like someone was like, "Oh, I noticed that n plus one equals n plus one," and then literally the whole thing came out of that. So just for being that crazy, Faultings. I get confused. All these number theory guys, I forget what they. Faultings theorem. It's about the finiteness of points. No, sorry. Yeah, curve of genus one over the complex numbers. Yeah, has finitely many rational points. Yeah, a known as Mordell conjecture until it's proved by Faultings. Yeah. I mean, it's pretty badass and overpowered. I'm gonna say A tier level stuff. A tier level stuff. Abel Ruffini is kind of weird because it has such a storied past of false proofs and different proofs and proofs that sucked until the Galois theory proof came along. I don't know. These other ones are just D tier. That's easy because I don't know them. Abel Ruffini though. Abel Ruffini. I don't know. How good is it? The thing is, it's not that well, it was kind of important to establish the unsolvability of polynomials in general. I'm gonna say A tier. I'm gonna say A tier. Such a struggle, such a team effort, such a long time coming, such a storied past, so much good story behind it. Um, Selberg trace formula. Uh, I mean, I think if I don't rank it high, I'll probably get fired from any of my jobs. GRR, didn't we do that? Did we do GR? No. Well, we did the index. We did the index theorem, and isn't that kind of part of GR? I'm confused about that. One, can't you prove one from the other or something? Let's put it in separately just to be safe. Reciprocity laws in I mean, that's too general. That's too general. Stone Weierstrass. That's a pretty good one. Nether normalization we did. Contraction mapping we did. Gödel we did. Schrader Bernstein we did. Harry Bell we did. Fundamental theorem of algebra. Generalized stonks we did. Is Birkhoff HSP theorem, which characterizes equational classes. D tier. D tier. I don't even know it that well, so D tier. Boom. Easy. Fundamental theorem of covering spaces. We did. Arzella Ascoli. Arzella Ascoli. Okay, Selberg trace formula. Yeah, literally, I'm gonna end up in jail or shot for not ranking this high enough. But I've never used it. And of course, that's the true sign. That's the true legitimate sign about whether Selberg trace for. Let me put this hat on as a disguise so people don't know who this person is that's ranking it like probably lower than it should. But Selberg trace formula. I mean, it's kind of everything for Langlands, though, right? So, like, oh, and Langlands is kind of everything. So, it's analysis, it's number theory, and those are the two subjects of math. So, Grothendieck Riemann Rock, you know I got to do it. A tier is definitely A tier. Is it S tier? It probably deserves to be S tier, but I gotta get you guys mad so you make more comments and promote me in the algorithm. Stone Weierstrass, again, amazing theorem, love it. Couldn't live my life without it, but it's just like a workhorse theorem. Fundamental theorem of algebra. It's got so many different incredible proofs, and none of them are algebraic. And I feel like that, like, I'm tempted to just make this a C tier theorem, but I feel like the sheer lower end amount of proofs surrounding this just pushes it into the B tier. And Arzela Ascoli, oh, is pretty good. It's pretty good. Yeah, but it also seems kind of like basic and workhorse-ish, you know? That's tough. I don't know. I'm trapped between a B and a C. I feel like we got to give the analysis people more. So a charitable B to Arzela Scully. How about that? Kaylee Hamilton slash Nakayama. I'll put it as Nakayama. Yeah. Matrix convertibility theorem. No, I'm not even ranking that. The six equivalent statements for invertibility of like determinant being zero. Nah, I'm not even ranking it. I don't care enough. uh, you know. Louisville's theorem from complex analysis, entire and bounded. Okay, okay. Louis V. Bought more Louis V. My mama couldn't get through to me. Hilbert null Stellensatz. We did null Stellensatz, right? Yeah, we did null Stellensatz, I'm pretty sure. Riemann mapping. We did that. No, wait. Did we do Riemann mapping yet? We did. No, yeah, this is about conformal mapping. So, no, we haven't done that one yet. Riemann mapping, 1 plus 1 equals 2 theorem, 2 basic. I don't know whatever theorem that is, but B triple T is instant D tier stuff. Never heard of it. Pythagorean theorem. Wow. Pythagorean theorem, generalized stonks. This is what I mean. This is what I was saying at the beginning of the video, you guys. Come on, like, of course, 4,000 people have already said generalized stonks. Oh, they did not get their wish. They did not get their wish. It is firmly in S tier. Daniel Kolmogorov consistency theorem or Kolmogorov Chentsov continuity theorem. I'll put it as a double feature in D tier because I don't know it. Poincare duality, we did. Law of large numbers. Monotone convergence theorem. And the snake we've done. Let's see, where are we here? How far down the list are we? Oh, we're getting close. And then I've got to switch over to Twitter, I guess. Nakayama, again, just amazing theorem, but just kind of a workhorse. So you're going to go there. Louisville's theorem is kind of crazy. So that's kind of mind-blowing. For mind-blowing alone, we're going to put it up in B tier. Kind of a shocker, TBH. Riemann-Mappin theorem. I'm at least gonna put it C tier because it is useful for practical applications, right? I think what's his name? Roger Penrose, talks in his book The Road to Reality about how you can use it to like take a plane's wing and deform it to a circular space or something. Is that true? I don't even know if that's true. Pythagorean theorem, of course, it goes S tier. How could we not? It's just so. Yes, it's so basic, but again, it's so ancient. It goes beyond everything and is fundamental to everything. You got to put some respect on it. Law of large numbers. I'm also gonna say, even though you guys may be surprised by this, but because I'm such a pure math boyo, but like I said, at S tier, I was willing to put what was it? I put some other statistics thing in S tier. Where did it go? Wait, didn't I put some other statistics thing? What did I put? Why can't I see it? Okay, I'm gonna put the law of large numbers here. Oh, central limit theorem I made A. Central limit theorem I made A. Yeah, I'm gonna put them both. I'm gonna put them both in S tier. We literally cannot understand the world around us without these theorems. So yeah, surprise. Durham theorem. I think we did Durham theorem. I'm pretty sure it's somewhere, right? Did we do Durham's theorem yesterday? Yeah, we did theorem already. Hilbert basis, did we do? Yes, we did. We did Hilbert basis. Lowenheim-Skolem theorem. Lowenheim-Skolem theorem. Dominated convergence theorem. And a T-Singer index theorem that's been done. Null-Stellen-Satz, notherization. Bézou's theorem. Okay, so I think we had the number theory Bézou, but we didn't have the algebraic geometry Bézou. Henkin's existence. Oh man, this person's gonna give me a bunch. Riemann-Roch compact Riemann surfaces. I mean, we have a much more general version of that already. Henkin's existence. Henkin's X. Fundamental theorem of abelian groups. Okay, I'll put it on there. And Poincaré. Okay, we've got a big batch here. Poincaré theorem. Okay, monotone convergence theorem. Yeah, basic. Lowenheim-Skolem. Which one is that exactly? Because there's the like Lowenheim-Skolem paradox, right? But Lowenheim-Skolem theorem. Right, on the existence of cardinalities. Yes, mind-blowing stuff. I don't even understand this theorem. I don't even understand it, but it's going in A tier. I don't even properly understand it, but it's going in A tier. Dominated convergence. You know, it's like a good workhorse theorem, which makes me think C tier, but it's also so basic that it makes me want to put it in D tier, to be honest. Bézou, I'm going to give definite C tier level basicness. Henkin's existence theorem. Let's see. Did we do this one actually? Why do I remember the name Henkin's from yesterday? Jenkins' existence theorem. Okay. Univalent functions, quadratic differentials. I don't know. I don't know it. D tier. Fundamental theorem of abelian groups. A finite rank abelian groups, right? That's what you mean. I'm willing to put it in C tier. Poincaré theorem. This is too crazy. It's got to go B tier at least. Poincaré theorem's pretty important, pretty interesting. You guys can't predict what I'm gonna do. There should have been. Oh man, we should have started polymarket best. Actually, I guess that wouldn't work because then I would see it and just have like insider knowledge and win instantly. You've been on group theory kick lately. Lagrange, Euler, the four nether theorems, the four horsemen of the apocalypse. Wait, what's Euler's theorem? Euler's theorem in group theory? Which one's that? Like every theorem is Euler's theorem. The Toshin theorem. Yeah. Well, let's see. Euler, Lagrange we did. Isomorphism theorems we're going to lump together in one. Cayley theorem. That's just UNA dilemma, so we've already placed it. And the CELO theorems we did. Existence and uniqueness of Haar measures on LCA. Yeah. Van Kampen we've already did. Moonshine we've done. Mean and pointwise ergodic theorems. Jewett-Krieger theorem. Zamaretti's theorem, I think we did. Von Neumann double commutant, Banach, Alaoglu, and the spectral theorem. I don't want to write all these. I don't want to write all these because they're all just going to be almost all of them are D tier. Well, okay, we'll go. Hang on. Ergodic, JK, the JK theorem. Zemaretti's, I think we did already. Von Neumann's double commutant. Von Neumann's double commutant theorem. An algebra consisting of bounded operators containing the identity, closed undertaking adjoints, strong. Okay. And Banach Alaoglu and spectral theorem. I don't think, did we do spectral theorem yet? I don't think we did spectral theorem. No, someone did say spectral theorem for some yeah, for Hilbert spaces. So I'm going to consider that as done actually. Okay, Euler's theorem. Again, for practical considerations, it will go in C because of its usefulness. Isomorphism theorems, again, incredible, but just too much of a workhorse theorem for me to be impressed. Haar theorem, Haar measure on LCA groups, existence and uniqueness, is kind of a crazy proof. The existence proof is kind of whack. And so I respect it more because the proof sucks. And my life wouldn't be possible without it. So, yeah, definitely B tier at least. Ergodic theorem, I don't know. This theorem, I don't know. Von Neumann, I don't know. D tier. Let me remind myself of the particulars of Banach-Alaoglu theorem. Oh, yeah, right. This theorem is pretty crazy, actually. It's kind of basic. I don't know. Kind of goes hard, though. Kind of goes hard. I'm feeling like a B. I'm just feeling like a B. First isomorphisms done. Reese, we did. Did not make S tier. United, we did. Vowel character theorem, Reese, we did. Van Kampen, we did. Stone Weierstrass theorem. Wait, did we do the Stone Weierstrass theorem? No, we did something else Weierstrass, right? Yeah, we didn't do. I don't think we did Stone Weierstrass. I don't think we did Stone Weierstrass theorem. I don't think we've done that one yet. Haar's theorem. Is that the existence and uniqueness of Haar measure? Haar's theorem? Yeah, I don't know. I don't know what you mean by that. Hexagramma mysticum? That's probably nonsense, but I just want to check in case there is a theorem. Sometimes we name things wacky like that. Okay, Pascal's theorem. If 6 points are chosen on a conic section, one of the few times I may not actually give it D tier just because I don't know it. Abel Ruffini we did, Cauchy we did, central limit theorem we did, growth and decrement rock we did. Extensions of AB are in bijection with X1 AB. Did we do that? Did we do that? No, I don't think so. I don't think so. Okay, let's go next. Bell-E's theorem. Snake lemma, we did vague conjectures. Vague conjectures. Yoneda lemma, the splitting principle. Splitting principle. Simplifies vector bundle problems by pretending they are sums of Lie bundles. Or in finance by dividing an extra loan. Wait, what? different meanings there. Okay. Yo, this MF be splitting. Splitting principle. I have seen it before actually. Fundamental theorem of Galois theory. I guess technically no one said that yet. Bolzano-Weierstrass theorem. Okay, how much further we got to go? Whoa, we're almost done here. Okay, Bolzano-Weierstrass. Wait, Bolzano-Weierstrass. Hang on. Which one's that? Convergence of a sequence. Has monotone subsequence. Proof of IVT. Okay, sequentially compact if and only if closed in bed. You know, I kind of feel like just calling this Heine Burrell. You know, because like Heine Burrell for RN. Well, mind you, I guess Heine Burrell is what technically the full Heine Burrell is like specific to certain kinds of metric spaces or something, right? Um, so I'm gonna consider that as absorbed in there. Jordan curve theorem we did. Sure, Zazenhaus. Um, I don't know if it's important. All four of them, I'm not doing them separately. I'm too lazy. Tikhonov, we did. Universal coefficient, we did. And Hanbanach. I don't think we did Hanbanach yet, right? Hanbanach theorem. Right. Hanbanach theorem we haven't done. Okay. Stone-Weierstrass. I'm actually putting this in A tier because it tells us that real analysis is a lie. We can do everything with polynomials, transcendental functions can suck it. Pascal's theorem, I don't know, seems very cool, but not interesting enough. X, um, X being in bijection with extensions in abelian category. I'm going to have to put that up in A tier. Amazing kind of classification theorem type stuff. Bell-E's theorem, D tier because I don't really know it. The splitting principle, okay. Vague conjectures. Tobo's theory wouldn't exist without the vague conjectures. No, is it S tier though? This is what I'm asking. This is what I'm trying to ask myself. Does it deserve to be up here? Does it deserve to be up here? With Gödel's incompleteness theorem and central limit. It kind of seems like yes, but I'm hesitating for some reason. The vague conjectures. Okay. I pause long enough. I do kind of feel like maybe it's just A tier. I do kind of feel like it's maybe just A tier. Done at me. No, actually, I guess now that I'm thinking about all the crazy Langland stuff, that it also opens up like you prove like Ramanujan with it. I don't know. It's crazy. Galois, honestly, where did I put the fundamental theorem of covering spaces? Because I feel like this is basically the same theorem, and so to be consistent, it should go to the same place. Wasn't that somewhere in B? Um, where's the fundamental covering space? No, did I put it in C? Did I put it in C tier? Um, could be in C tier. No, but you know what? Even if that was in C tier, I'm gonna put it in B tier. It's too important. Um, it kind of belongs in A tier. It kind of belongs in A tier. Too late. I took my finger off. I'm not going back. Splitting, yeah, I don't know. Seems important. Just kind of a workhorse theorem, though. Um, really, is it as important as orbit stabilizer though in Nakayama? I don't know if it even deserves. It might even be D tier, but it's too late. I took my finger off. Sure, Zazenhaus I think is just D tier. Uh, right? Uh, sure, Zazen. Oh God, I can't even spell it correctly. Maybe I'll copy paste it from someone that spelled it correctly. Uh, wait, where did it go? Who said sure Zazenhaus? Oh, here we go. Sure Zazenhaus theorem. Uh oh. This was not what I was thinking it was. Um It's a theorem in group theory which states that if G is a finite group as a normal subgroup whose order is coprime, then the order of the quotient group is a semi-direct product. That's too basic. That follows from like others. That's too basic. Too basic. Interesting, important, but too basic. Han Banach, let's say B for Banach. Where would we be without Han Banach? Okay. Wow, we're almost through it, and hopefully Twitter will just be full of people uh, making the exact same suggestions. Um, making the exact same suggestions. So let's go see where. Okay, 128. Okay, we can do this. We're in the home stretch. This is all going to be same thing as before, right? GRR, Atiyah Singer, vague conjectures, we've done. Geometrization theorem, we haven't done. Classification of finite simple groups. Geometrization theorem. Thurston's geometrization conjecture, but hang on. Geometrization theorem. Wait, which one? Probably this. Wait, so is it you just mean wait, what does it mean? Topological, certain three-dimensional topological spaces have unique geometric structure. So it's now a theorem, huh? He announced proof. Oh, this is wait a second. So I see. So it's more than just Poincaré. I thought he just proved Poincaré, but I guess is this a bigger statement, or I guess it had been just reduced to resolving Poincaré? Is that true? See, I don't even know. Um, I feel like because of the extreme goated legendary status, it's hard to not give of Perelman's work. Hard to not give that S tier. Univalence axiom is an axiom. Monotone convergence theorem. Is that what they meant? Yeah. Gordon's escape theorem. Isoparametric inequalities. Gordon's escape theorem. No, too obscure. D tier for sure. Uh, Gordon, boom, D tier. By isoparametric inequalities. Yeah, too basic. Bye. Bye. Banished to the D tier. Banished to the D tier realm. Hodge theorem, I think we did. Riemann-Lebesgue lemma. Riemann-Lebesgue lemma. Did we do that one? Which one's that? Ooh, that's kind of important. That's kind of important. Riemann-Lebesgue, okay. And Pointryagin duality theorem. CeLO existence. I'm gonna call that as part of the CeLO theorems. Art and Wedderburn. I don't know. Hopkins. Sorry, Art and Wedderburn. We did this one. Semi-prime ring and a module descending. D tier. D tier. I don't know it well enough, so D tier. Okay, Poincare duality or Pontryagin duality theorem. I love it. One of my favorite theorems, but also the thing is, if we bump this up to Tanaka duality, which could be viewed as like a great generalization of this, then maybe I'm putting it higher. Geometrization, I feel like we just got to put it S tier because of the legend around it. Riemann-Lebesgue, where would we be without signal processing and stuff? So I'm gonna put that in A tier. Okay, maybe this was a bad idea. Twitter's got all of these. Twitter's got some pretty crazy ones I've never heard of. Chern's theorem. Do I know that one? Chern Gauss-Bonnet. I think we did Gauss-Bonnet. Yeah, so we've done it. I don't know those other two theorems. I don't even know those other names. The JR theorem and the BV theorem. Never even Bumbari I've heard of, but I've never even heard of those other guys, so instant D tier. Gower's dichotomy theorem. Gower's dichotomy theorem. Any infinite dimensional Banach space either contains a subspace with an unconditional basis or hereditary indecomposable. So, okay, let's see. Gower. Spectral theorem we did. Stokes we've did. Nether we've done. Rank nullity. Cauchy. Schur's lemma. In representation theory, I don't think we did that version. I don't think we did that Schur's lemma. Fundamental theorem of Riemannian geometry. I think we did technically do, right? I think we did technically do. No, that we haven't done that. Fundamental theorem of Riemannian geometry. And image equals domain mod kernel. Yeah, first isomorphism theorem. We already ranked. Spectral, stonks, first iso. All of those we've done. Radon Nicodim we don't have yet. Radon. Okay, it's already in there by accident. Poincaré Benedictson. I don't know it. So let's go D tier. Boom. Gower goes in D tier, sorry. Sure. I'm gonna put in C tier. Fundamental theorem of Riemannian geometry. I'm gonna put actually up in B tier. I'm more impressed by it. Actually, no, it's a C. Well, no, I dropped it too late. I was gonna change it down to C tier, but Radon-Nikodyn theorem. Um, Radon-Nikodyn theorem. Yeah. So, Finite measure, Yeah. What does it say? It says that basically every measure can be like written like this or something, right? I'm gonna put it in C tier. Yeah, kind of a workhorse theorem. I don't know. Lurie's straightening and unstraightening lemma. Picture for reference only. Straightening, unstraightening lemma. I don't know how much I can show that in my video. Straightening, unstraightening lemma. Okay. We'll write it like that. Peter Val, we did Krein Milman. Never heard of it. Instant D tier. Class groups of number fields are finite. Okay. I don't know where to put that. Does that matter all that much? I don't know. Like if someone had proved a theorem, I don't know. If we knew all the class 1 fields ever, right? That would be a crazy theorem. But is just finiteness of class number? I mean, it is pretty badass, and it does relate a lot of algebra, number theory, and geometry. Yeah, well, uttering Zorn, we've been there. Gödel, we've been there. Mostowski collapse lemma. Also D tier because I've never heard of it. Lose theorem of ultra products. Technically, we have continuum hypothesis already. Fourier transform is not a theorem. Central limit theorem we've done. Wait, there's one other here. Oh yeah, theorem on ultra products. Don't know it, so it's going in D tier. Instant D tier. Not a theorem, but a result and a gorgeous one. Ekman-Hilton argument. Yeah, not quite a theorem though. It's kind of just an argument, right? Well, there is sort of like a general theorem there about like commuting monoids. Or having two products on a monoid, right? So, there's a theorem version we could say. Stone representation theorem. Let's see, how far are we through this post? Okay, we are. Wait, but it's gonna load more, isn't it? Oh my god, it just goes on. Oh my god, it just goes on. Okay, you know what? I am calling it quits here again. I probably won't make a separate video, but I will maybe paste these all together. Yeah. So hang on to your hats. Okay, so we're entering the third part of this video, and I've still been tired and grumpy the last few days. So here's what we're gonna do. We're gonna forget typing it into the actual physical tier list because that's getting annoying, and we're just gonna yeah, we're just gonna power through And I'm just gonna say out loud what tier things are in. I'm sorry. I know it's not as interesting, but gosh, there's just a lot more than I expected. Okay, stone representation theorem for Boolean algebras. I don't think we've done that. Stone representation theorem for Boolean algebras. This is pretty cool, if I recall. Yeah, the stone space. Points are ultra filters. States that every Boolean algebra is isomorphic to the algebra of clopin subsets of its stone space. I'm gonna call this a C tier. I'm actually gonna call it a B tier theorem. I don't know. Don't judge me. Or do judge me in the comments and drive me up in the algorithm. I don't know. It just feels like B tier. Ekman Hilton, I think we talked about. Bezout. Okay, Bezout in the algebraic geometry sense. Bezout in the algebraic geometry sense, I'm going to call C tier. I don't know Bondel. I'm gonna call it a D. Auslander-Bousbum formula. What is that one? What's this one? Serre's criteria for normality. I don't know. I'm gonna call it D tier. I'm gonna call it D tier. Sorry, not sorry. I'm not that fascinated by it, TBH. Okay, what's the Buchsbaum formula? I know I've seen it before. Oh yeah, about height and depth. I'll call this C tier. Pretty useful. Kronecker-Weber theorem. Let's say Kronecker-Weber theorem is A tier. Actually, Kronecker-Weber is so based. I know I'm really exposing myself as a, number theorist. Maybe I should be more of a number theorist than I am. Oh, I didn't mean to do that. Chern-Gauss-Bonnet. Brown representability. What's Brown representability? Brown representability theorem. Homotopy theory gives necessary and sufficient conditions for a contravariant functor on the homotopy category to be representable. I'm also going to call that... Ooh, that seems pretty powerful, though. Still, I'm going to call it a C-tier theorem. Green Tau, I think I ranked... crazy 100 plies, don't mention the go. Okay, we did Chinese remainder theorem. Yeah, I think I put it in S tier. H-cobordism theorem. I think we did that, right? We did actually do that. Theorem that holomorphic is equivalent to analytic. Technically, I think that's a consequence of Gersat's theorem, a quick consequence of it, kind of. So I'm going to consider that as done. Cauchy's integral formula. I think we also did talk about that. Is going to have a totally schizophrenic list. Yes. A couple came to mind. We did Borel, Weibot. Wait, I didn't mean to love it. I should have liked everyone's comment, actually. I don't know why I unliked it. Borel, Weibot. We haven't done. Serre's Gaga theorem. I am Gaga for Gaga. We're going to call Gaga tier A. Borel, Weibot. We're going to call tier B. We've already done this, I think. I still haven't looked up how to say his name correctly. Haven't heard of it. D tier. Krein, Millman, I think we did. Or is there a single theorem? Or's theorem for a graph to be Hamiltonian. Sufficient condition for a graph to be Hamiltonian. C tier. Banach fixed point we did. Lagrange 4 square. I'll call it C tier. Kind of basic. Borel Cantelli. Which one's that? Which one's that again? Measure theory gave a statement. Borel can't tell if the sum of probabilities, then the probability that infinitely many of them occur is 0. I don't know. That's kind of D tier. Too basic. Too basic. Maybe it's hard to prove. I don't know. Have I've perhaps in what's a shock to a lot of people. You know, we've had a lot of stats. We've had a lot of stats. You know, up in the S tiers here. So y'all should be thankful that this pure boy is given so much love to the stats. Keely Hamilton, we did. MVT, IVT, EVT, we didn't do. I feel like the same. I'm not even gonna rank EVT. A quote from Cantor, I guess. Radon Nicodim, we did. Heine Burrell, we did. Tuesday Classics, Banach's fixed point theorem. We did. Very fun examples of proof of Hutchinson's theorem. Kuratowski theorem in graph theory. Wait, what's a Kuratowski theorem in graph theory? What is the Kuratowski theorem in graph theory? Let's look at that. I don't know if I've heard of it. But it's a fundamental test for planarity. Planar if and only if it contains a subgraph with subdivision. Ooh, that is easily B tier, if not even A tier. It's a pretty cracked theorem for planarity. Pretty cracked result for planarity. So I'm gonna call it a high. I'm gonna call it a high B tier for sure. Weierstrass approximation, I think we did. Harry Ball, we did. Picard Lindelof. Which one's that? Picard Lindelof theorem. Closed rectangle, point in the interior, continuous Lipschitz, continuous. Any unique solution here? How crazy do I feel about this? It's okay, I guess. I'll call it C tier. I'm gonna call it solidly C tier. Piano existence theorem. Piano existence theorem. Fundamental theorem which guarantees the existence of solutions to certain initial value problems. Wait, isn't this just the same thing? Wait, why does this look like the same damn theorem we just read? D tier then. D tier. We've kind of done similar things to closed graph theorem. We did. There's like a couple of results that are all mushed together in functional analysis. Kakutani fixed point theorem. I don't think we have that. Fitting lemma, I think we did. Constant rank theorem. I don't know about that. Kukatani fixed point theorem. No, never heard of it. So D tier. Fitting lemma, we did. Yeah. Constant rank theorem. Constant rank theorem. Wait, is it just the inverse function theorem? If the rank is constant, then there's a neighborhood of D pheomorphisms. I'll call it B tier. I'll call it B tier. Why not? Deserves B tier. I think we've done everything else. Borel Cantelli? Yeah, we talked about Borel Cantelli. Well, for me, it was a day ago. For you guys, it was 20 minutes ago. Yeah, we did it. Classification theorem over PID. I think we talked about spectral theorem. We talked about the goats. We talked about Hilbert correspondence. Riemann-Hilbert correspondence? Oh, the Riemann-Hilbert. Well, why over say CP1? Riemann-Hilbert correspondence. Again, this is another one that it's like, um, I'll probably be sent to a work camp for the rest of my life for being in my research area and not rating Riemann-Hilbert high. Uh, oh, yeah, there's some crazy big stuff that it unlocks, though. Does unlock some crazy stuff. So I'm going to have to put it in A tier. We couldn't understand the E8 lattice if it wasn't for the Riemann-Hilbert correspondence. BT dubs. Ham sandwich theorem. Did we talk about that one? Ham sandwich theorem. Result in measure theory. No, we didn't talk about this one. For every positive n, the ham sandwich theorem states a given n measurable objects in n-dimensional Euclidean space is possible to divide each one of them in half with a single n plus 1 dimensional. Oh. Ooh. 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 I am, guess what? I'm actually, okay, we're going to go back to the list for a second. We're going to go back to the list for a second. We are going to add in ham because it properly needs to go in the S tier, actually. Look, most practical math theorem that's ever existed. It says there's no excuse. You should always be able to share your sandwich with your friends. That is, if that isn't an instant S tier result, then I don't know what is. Easy. Furstenberg multiple recurrence. Furstenberg multiple recurrence. You know, maybe I should keep this over the side. Maybe there's more that I'd be willing to. Maybe there's more I'd be willing to put on the list and not be so lazy. Measure preserving system, probability space, bijection, both are measurable, positive measure. Okay, what does this mean? Oh, it's equivalent to Zamaretti's theorem. Well, we already did that one, so too bad, so sad. I know there's all these dynamics people have made mad in this video. As a palate cleanser, an easy one to start off the tiers, please review basic theorems of calculus. No. Oh, come on. Everyone suggested those theorems. Your favorite you've encountered thus far is the proof of set that is not Lebesgue. Ooh. Yeah. Pretty crushing the existence of non-Lebesgue measurable sets. Am I just feeling better because I don't know, I'm tempted to also call this one S tier because it's kind of a shattering thing. Non-Lebesgue measurable sets, kind of an earth-shattering thing. Yeah, what can I say? So let's put it, I'm going to put that up in S tier as well. The Soul theorem / conjecture. I don't know that one. Reese, we did bot periodicity. What's the Soul theorem? Complete, connected, non-compact Riemannian manifold. D tier. I've never heard of it. Bot periodicity. Bot periodicity is let's say an A tier theorem. Compactness theorem and model theory. Compactness theorem and model theory. A set of first order sentences has a model if and only a finite subset of it has a model. Yeah, this is somehow related to the Lowenheim Schoolum. I don't understand it, but I respect it, and I'm gonna call it an A tier for that reason. Scary logic stuff that I want to understand one day. It's actually not that scary. It's like, well, you learn it in like a basic like undergrad logic course, maybe an advanced logic course. Upward, downward, Lowenheim Schoolum. Alternatively, Cantor, Schrader, Bernstein. I think we ranked that one already. I think we've already talked about. Wait, but did we talk about upward, downward? I don't know. Implicit function theorem. That implicit function theorem is I'm gonna put in C tier. There's nothing wrong with being in C tier, by the way. Most of you probably get C's in your classes. Oh lordy, have I gotten C's in my classes, so don't you worry about it. Downward states an infinite structure has an elementary substructure of any smaller infinite cardinality, and the upward says that any structure theory with an infinite model has elementary extensions of any larger. Okay, I'm gonna drop that in B tier actually. No, it's actually, well, I don't know how hard it is to prove. It seems obvious, right? It seems obvious. It's probably hard to prove. I don't know how to prove it. Whatever, I said B tier. That counts as me dropping it in. You know what I mean? You knew the math heads would beat you on naming the big ones. So you think more recent, the third Kekaya. Um, hmm. 2D case you recall in some pop math book in college. Thought it was clever, but not much more. Yeah, I guess it's kind of a big deal. Hmm. It's a big deal, but does it? I'm gonna give it. It's probably crazy if I rate it too low and someone's like winning a friggin' Fields medal for it. You know what I mean? Like it would be insane for me to do that. Okay, I'm just gonna call it an A. I'm just gonna call it an A. People include more theorems in combinatorics. People in comments completely forgot about discrete math and some. That's not entirely true, but definitely. Oh God, how many did you put here? Oh, oh Lord, I'm trying to speed run this right now. Oh my God. And you put helpful, useful things for me to learn more about combinatorics. Good Lord. Um, but actually, you have a good point. There's theory developers do seem to get more respect and reverence than problem solvers. I'll grant you that. The two cultures, original article, the two cultures of math. Um, Interesting. But yeah, oh god, there's so many. Okay, Ramsey theorem. Ramsey theorem, let's call it B. Euler polyhedron theorem, I forget. It's kind of a classic one, right? Isn't this, yeah, V minus E plus F. Pretty goated actually. We're going to call that one an A. We're going to call that one an A even though it's pretty basic. The Turan theorem, I'm probably saying that wrong. Nikolai made fun of the fact that on my current keyboard, unlike the one I usually have, I have to look as I'm typing. That's true. Skill issue, but still. Now I'm self-conscious about it. Bounds the number of edges that can be included in undirected graph that does not have a complete subgraph. Extremal graph theory. I don't know. I'm gonna call it a. Is it even C tier? I don't know. It's cool, but I don't know. How often do people cite this theorem, for example, when doing this stuff? Maybe often. I'll call it C tier. I'll call it C tier. Kuratowski. Okay, I talked about Erdős Corrado. I think this we did. Someone mentioned Corrado, right? Rado, whatever. Um, can say? Probably me. Limits the number of family sets in which every two sets have at least one element in common. Ooh, Yeah, I don't know. It's kind of basic though, so I'm gonna put in D tier. Four color theorem, I think we already made S tier. Art gallery problem. That sounds familiar. Did we do it? Eulerian path problem from Königsberg's? No. No. Maybe Euler's theorem ranks heavier, but it's too basic. I would call it. Well, okay. Again, here's the thing. You got to try and understand the psychology of how I'm ranking this list. I love that theorem and I love that story and it's great for teaching. Okay, so maybe I put it higher. Maybe, I have not been thinking about the pedagogical benefit of every theorem on this list. So I'm going to call it B tier, okay? Are you happy? I'm going to call it B tier. D tier. D tier. Calling this one D tier. Hockey stick theorem. Did we do this one? I can't even remember. I've read so many theorems because of you guys. Something regarded algorithm. Okay, come on. You really ran out of steam on that last one. Hockey stick identity. Nah. Oh no, that's way too basic. I'm not even putting that on D tier. And or Lax Milgram? I'm gonna say no because he said and or. Universal function approximation theorem. Arrows we did. That crazy one you wrote there I've never heard of, so instant D tier. Halting problem, kind of related to Gödel. Obviously, halting problem is S tier. But is it separate from Gödel? It is, but it's kind of the same. What am I doing? Why am I being weird about it? Yeah, we did universal approximation theorem. No, still in thoughts we did. Jordan, curve theorem, Lever, Cauchy, done. Krull, Remark, Schmidt. There's a mention here. I didn't know Azumaya was attached to it as well. You're probably right. Krull-Schmidt group, finite conditions. I don't know. C tier, workhorse theorem. Tom's theorem? Who's Tom? Freudenthal we did. Brown representability we did. Lefschetz Poincaré duality. Yes. Bot periodicity we call it all. Tom's theorem is what? The Tom isomorphism? If it's just the Tom isomorphism, then I don't know. I'm putting it maybe Tom's theorem. Let's see what NLab has to say about it. Pointryagin Tom isomorphism given a universal tangent structure. D tier. Sorry if I have to read too much. It's D tier. Pointryagin Tom? Is that different than Tom? See, I can't even keep up anymore. Nether theorems we already talked about. I think we talked about the iso theorems. They're somewhere on here. Somewhere, I think, if you just see the word iso. Did I put it in C tier? It's kind of wild for me to do. Yeah, wow. I can't believe I did. Well, whatever. Too late. That's where I put it. Tom space, Tom complex. D tier. Inscribed angle theorem is specifically moving the vertex. Yeah. It's not an epsilon delta theorem, but still one of your favorite pleasant surprises. Yeah, it's nice, but I'll call it like D tier at best. Bayes' theorem. Uh, yeah, it's too basic. D tier. Straightening, unstraightening, we talked about. Dirichlet unit theorem. Wait, did we do Dirichlet unit? It sounds familiar. Did we do Dirichlet unit? Uh, no, I don't think so. We did arithmetic progressions. No, I'm sure we talked about Dirichlet's unit theorem. I'm calling it B tier. Even if I did it, I'm calling it B tier no matter what I called it before. All of these we've done, we've done. Ping pong lemma. Wait, I don't know if I did the ping pong lemma. Also, how do I like tag everyone that responded to this to tell them what my uh, I guess I just post on Twitter. Table tennis lemma is of any several mathematical statements to ensure that several elements in a group acting on a set freely generates a free subgroup of that group. I don't know. D tier, too basic. Sorry. Sounds cool. Pigeonhole principle, which says that if you drill n plus 1 holes into n pigeons, one pigeon will have at least 2 holes in it. Yeah, too basic. Not even D tier. Those have been covered. Hochschild Constant Rosenberg theorem. Ooh, existence of Nash equilibrium. I guess I'm gonna have to call that A tier. Nash equilibrium's A tier. What is this? Some crazy homological algebra. I don't know. Seems based, but D tier. I don't know it. Too obscure. Kirchhoff's theorem. Hensel's lemma. I think I ranked Hensel's lemma already. I don't know what this one is, though. I don't know what this one is, though. States that sum of reciprocals of any consecutive sequence of integers is never an integer. Kind of badass. Kind of badass. Kind of badass. Kind of badass. Gonna call it. But it's like not useful. C tier. I'll call it C tier. Heisenberg uncertainty principle. It is technically a mathematical theorem. Let's say. Is it? Yeah, I mean, it's just such a goated meme at this point. Heisenberg. Um, God, but does it really belong? No, I will call it. A tier. Well, it's pretty crushing for the real world, no? But you know what? We were never going to know those things that precise. Well, okay, I'll do S tier. Fine. Okay, all of these have been done. This is one of yours, more in the video. You will link in the first comment. Uh, what's the actual theorem though? I don't see anywhere. I don't see where it says theorem. I don't see anywhere. Theorem, maybe theorem something. God's binomial coefficient identity with conversion symmetries. God's binomial coefficient identity. That's quite the name. This is definitely D tier stuff, though. That is, uh, that is maybe a crazy thing for me to say. Maybe you're like a researcher or something. You're a feral mathematician. I mean no offense, but fairly unknown theorem about some combinatorial identities. I'm gonna put it in D tier. Green Tau theorem. We already did that. Unified structural theory. Okay. If I want evidence. Okay. Diaconescu's theorem. Tarski undefinability. I don't think we did Tarski undefinability. Did we? I don't think we did. I don't think we talked about that one yet. I don't think we talked about Tarski's undefinability theorem. Yeah, no, we didn't do this one. States that the axiom of choice is sufficient to derive. Why even call that? Really? That's named after someone? Really? That's named after someone? I don't know. Like kind of important, but like also D tier. It's kind of a basic result, right? And like not shocking. Any sufficiently complex formal language, truth within that language cannot be defined in the same language without leading to a paradox. Yeah, I mean, what else am I gonna do but Tarski T S tier theorem, like devastating, absolutely devastating, um, absolutely devastating. So, Cauchy residue, we did. Nether, we did. Large, we did it. Happy, generalized happy end theorem. Hurwitz, I think we did. Riemann Rock, we've talked about. And its generalizations. States that for any integer bigger than 2 in the plane, D tier theorem. Königsmann's universal definability of Z. Oh, God, why isn't my laptop plugged in? Hours into this video, and now I'm going to make you guys watch me reach over and grab for this. I wonder if probably my face has gone out of sync with the video because it wasn't plugged in. I don't know. Okay. Of Z in Q, or at least Robinson's definability of Z in Q. I don't know. D tier. D tier. I don't know. Galois theory, we did. Chewing through the bars. Cartan Dieudonné theorem. I don't know. Smells like D tier to me. I don't know what theorem this is. Cartan Dieudonné. Every orthogonal transformation, n-dimensional symmetric bilinear space can be described as a composition of at most n reflections. Ooh, actually, instead of D, I'm going to call that one B. That's a pretty nice theorem. Bolzano-Weierstrass, we did. Apollinus, Apollinus, I don't know. Sturm-Liouville? We did Sturm-Liouville, right? We did Sturm-Liouville. Wait, which one's Sturm-Liouville? How do you spell Louisville? God. If anyone's still watching, you're sick. Who would have watched this far? Wait, Sturm-Liouville theory. What's the Sturm-Liouville theorem, though? Is there a theorem? Is it Miss or is it Mrs.? The theorem concept in differential equations. I don't know. Seems like one way to solve one class of differential equations. Is it that crazy? I don't know. Apollinus and polarity. I don't know what the actual theorem is here, though, so I'm going to just... I don't know where to put it. D. Wait, Sturm-Liouville. I just looked at it. Why can't... Oh, yeah, Sturm-Liouville. D. Fubini and Tonelli. Nobody's mentioned these yet. C tier, both of them. Workhorses. Love them, but Tate acyclicity theorem. Did we talk about this? I can't remember. There's so many. All the names are running together. So many. We've talked about ones that are called cyclic or acyclic. This is about cohomology, right? No, totally wrong. D tier. Who knows what an aphanoid even is? These we've done. Those we've done. Fisher's theorem. Fisher's theorem. Let's have a look at Fisher's theorem. Fisher's theorem usually refers to Fisher's fundamental theorem of natural selection. Whoa, I don't think that's Reese Fisher. No, I don't know. Fisher's fundamental theorem. Okay, I don't know. I don't know which one this person's talking about. That's been done. That's been shadow lemma. Shadow lemma. How mysterious. What's the shadow lemma? I want to know. Has my face been cutting off everything in Google the whole time? No, it hasn't been that bad. What's a shadow lemma? Shadowing lemma. Dynamical systems, pseudo orbits, near hyperbolic invariant set. D tier, because I don't know what that was. Oh, in pop culture? Yeah, D tier. Sounds cool. Sounds cool, though. The rank theorem for manifolds? Rank theorem for manifolds. Rank theorem for manifolds. What does that say? Smooth manifolds mentions Mn, constant rank. Then there's a smooth chart and a smooth chart such that. I'll call it, wait. I swear we did this one in a different guy. I swear we just looked at this one earlier today. I'm pretty sure I called it C tier then. I'm calling it C tier now. The side splitter theorem. Side splitter theorem. Also known as the triangle. That's too basic. Sub D. Calling that a sub D theorem. Quillen's theorem A. Oh, good lord! And you have a whole bunch of. Okay, D tier. I don't know that bottom one. Don't know that one. Don't know that one. D tier. D tier. Dold-Kahn correspondence. We're gonna call that A tier. Leray Hirsch. Leray Hirsch theorem. Leray Hirsch. Ooh, yeah. Computing topology of fiber bundles. Generalization of Cronus formula. Workhorse theorem. We're going to call it a C. Representability of presheaves on presentable categories. I don't know. We'll call that C tier as well, I guess. What's Quillen's theorem 8? Didn't I just Google this? What the hell? Yeah, if it's a comma category, contractible, induces homotopy equivalence. D tier. Too obscure. Sorry for you were too obscure. Dudley's theorem and Sabanko theorems. Dudley's theorem. We're really digging into the deep weirdo stuff here. Yeah, D tier, too weird. Why did I know I didn't know the name. Atsabanko, D tier. Dwisterman Heckman. Okay, I've seen this, I think, in a thesis of one of my supervisor's previous students. So, but I forget what it says. Push forward of canonical measure on a symplectic manifold under the moment map is piecewise polynomial. D tier, too obscure. Peter Waal's theorem, I think we did. Inscribed square. The inscribed square theorem. That's my favorite theorem. Inscribed square. Peter Waal. Oh yeah, matrix coefficient stuff. Ooh, for unitary representations. Oh, gosh. Gosh darn it. I kind of want to call this B tier. I'm going to call it B tier. I'm going to call it B tier. Whatever. I called it B tier. The deduction theorem. Abel's lem. Abel's lem. What's Abel's lemma? Deduction theorem. Ooh, fundamental rule mathematical logic says you can prove a conclusion B by assuming hypothesis A from a set of premises, then you can prove the conditional statement A implies B from just the original premises alone. I don't get it instantly, and therefore it's a D tier. Abel's theorem. Which one? Several concepts. Different. Okay. Oh, the Wronskian. The Wronskian. I don't know. I'll call it C tier. Solid C tier. Urzella 1 and 2. I already ranked it technically. And Shannon Nyquist. Okay, Shannon Nyquist probably is going to go higher up because of its real world applicability. It actually means something. Sampling. I'll call it A tier. I'm gonna call it a solid A tier result. Ulam, we did it. You kind of have one, but not a mathematician, so you don't know what to do with it. Your own theorem? Well, that's good. We support people proving their own theorems here. Nastertarsky. Okay, I don't know what it is, so D tier. I gotta end this video eventually. Quantum entanglement and its connection to telepathy. Well, I'm not aware of any connection to telepathy, so Honey Burrell, we've done. Lowenheim, Skollenheim, we've done. Kuratowski, we've done. Courant-Fisher min-max theorem. Courant-Fisher min-max theorem. Min-max theorem. Algebraic functional analysis. Result that gives eigenvalues, compact Hermitian operators on Hilbert space. C tier. Useful. Oh no, what did I just do? Oh no. Oh no. I lost where I was in the post. Pray for me, friends. Pray for me in this late hour, in the very end of the third part. I don't think it rearranged the order of the comments, right? Show probable spam? Absolutely, we want probable spam. Oh Lord, please. I've had this tab open for days. No, it looks like it rearranged. No. No, it looks like it rearranged the comments because these comments weren't at the end before. Oh Lord. Okay. I've gotta uh um okay. Okay. Uh no, maybe these are mostly in order actually. I was freaking out for a second, but this does look like it's still mostly in order. So maybe it's okay. A couple got jumbled. But I'm not so. I think I covered everyone, right? Um, maybe we really were there at the end. Post was deleted. Yeah, Abel's. Okay, here we were. Wick's theorem. Okay, there's one that we missed. Wick's theorem. Let's see. Method for reducing higher order derivatives to a combinatorics problem. I don't know. That notation scares me, so I'm gonna call it a D tier. No, C tier. It looks useful. No, I said D first, so that counts. Gödel's speed up theorem. Oh, that is yes. Gödel's speed up theorem. It's a good thing I went back. Gödel's speed up theorem. Can he help me speed up the end of this video? Proved by Gödel shows that there are theorems whose proofs can be drastically shortened by working way more powerful axiomatic systems. Right. Hmm. Is this proof constructive though? Is this proof constructive? I don't know. I'll call it like B tier. Um, okay, there was some. Okay, I think we're good. There's some that I missed, but I'm seeing some familiar ones again. Uh, yeah. Green Tau from Matt, inscribed square. Duh, duh, duh. Yeah, we've seen these posts. We've seen these posts. We're almost at the end. Uh, mm, oh my gosh. I think that's it. I think that's it. Because we didn't have that much more to go, anyways. So I think we did it. Final probable spam. Sorry, George. I don't know why you're considered probable spam. Stone's theorem that states that every compact separated topological space is uniquely defined by algebra C to the 0. I'll call that final one D tier. So, final rankings. Of course, not everything, as you know, I didn't write everything down on this list. Uh, for the last hour of this, I neglected to write things down. But we are going to review the theorems that I consider to be S tier, God tier theorems. Of course, the modularity theorem, geometrization theorem, proof of Poincaré essentially, Atiyah-Singer index theorem. Even though it looks like I didn't have growth and decrease in rock reach the top, I don't know if I actually still believe in that as an S tier choice. To be honest, I don't think it's on the level of the other two things. Um, it's kind of too late. I said lots of times that I'm committed to choices I make, but I do regret it. Classification of finite simple groups easily in here. GIMP comp, of course, I mean Gödel's incompleteness theorems. Lever fixed point theorems, because really that's just a generalization of Cantor diagonalization. Where would we be without that? Harry Ball, because of the meme. Four color theorem, absolute legend, computer assisted proof, controversial, huge deal. Continuum hypothesis, for being one of the first real problems, independent problems that we cared about separately before we even knew about independence. So independence of continuum hypothesis. I mean, moonshine, for just being batshit crazy. Who could have possibly have dreamt of it? Pythagorean theorem, ancient classic. Got to put some respect on its name. Vague conjectures. I mean, these went on to be important in things beyond number theory, even because of the development of topos theory that led to it. Central limit theorem, law of large numbers, group these ones together. Super useful for the real world. Literally could not understand the real world without it. Everything's statistics at the end of the day. Non-Lebesgue measurable sets. Well, these last ones I talked about already in today's video, right? Non-Lebesgue measurable sets. Um, Mind-blowing. What did I mean by ham? Heisenberg uncertainty, Tarski undefinability of truth. What did I mean by ham? I don't even remember. I just put that one here today. I don't even remember. My brain's so fried. That's it. That's the end of the video. I hope you guys are mad. I hope you're real mad and you're driving up engagement in the comment section about how you disagree with everything I said. But I love you all, and QED.